Hey, what's up everybody? It's Sim Safdar and you are listening to the CloudNative.fm podcast. I'm excited and thrilled to host this show for you. And this is episode number 13 of CloudNative.fm podcast. Today is May the 1, 2021, and in this episode we are joined by Kelsey Hightower to discuss the evolution of cloud infrastructure management, the role of Kubernetes and its API play in it, and how we as developers and operators should be adopting to these changes. And we are not going to disappoint you, but to make your time extra interesting, we're also going to cover this in detail: the past, present, and future of Kubernetes, service meshes, GitOps, serverless, and much more. So let me introduce my guest. Kelsey Hightower has worn every hat possible throughout his career in tech and enjoys leadership roles focused on making things happen and shipping software. Kelsey is a strong open source advocate focused on building simple tools that make people smile. When he isn't slinging Go code, you can catch him giving technical workshops covering everything from programming to system administration. If you want to see what he's up to, follow him on Twitter, Kelsey Hightower. And let's go ahead and say hi to Kelsey and cut it over to the interview. Thank you everyone for joining us today. This is CloudNative.fm podcast, and I'm your host, Sim Safdar. And today, this is episode number 12. And today we are talking about the past, present, and future of Kubernetes. And guess what it is? My guest is today. That is Kelsey Hightower. I don't think so you need any introduction, but he's a principal developer advocate, I think, in the Google Cloud team, the Google team. How are you, Kelsey? What are you doing, and what the COVID time is going for happening in your area?
Hey, happy to be here. I'm doing well. There's definitely all the COVID things to deal with. I got my first vaccine shot, looking forward to get my second. Pretty fortunate to have access to the vaccine. And in terms of work, even though I spent a lot of time with Kubernetes, I also spent a lot of time on the serverless side. So Kubernetes is where I spent a lot of my time over the last 5 or 6 years. These days, I'm really looking to see if serverless is going to bring an operational model, not just to compute and containers, but to databases, networking, and all the other things that people have been trying to do in the cloud native space.
Yes, definitely. I think ever since the AWS Lambda came into the picture, I think way back in 2014, AWS reInvent, everybody is thinking about abstract away the platform from us. We don't manage that infrastructure. We have some AWS Lambda service for our side. Just focus on the application logic that the business needed, because millions of users are using the coding business logic. They never heard of think about the infrastructure with the application residing. So I think serverless is a way too forward. But for me, that is a pleasure to talking to you. I feel a bit nervous for right now, talking to one of the industry's ever known personality, and is also a very friendly guy. I know from there a lot of the Kubernetes ecosystem. So I talked to today, or we tried to cover the whole cloud native ecosystem, but without the first question for that topic in my mind when I first see the Kubernetes. So let's say if 2021 don't have a Kubernetes, how we run containers, and what are the technologies then before in the when the Kubernetes and Docker is not even there?
Yeah, I think one pattern that was actually pretty good and still pretty good, if I was writing an application, like when I used to write applications around 2010, I was always putting my application in RPM packages. So even though we use containers now and Dockerfile, back then I was using RPM spec files. And for my Java applications, I would, package up the war file. I was using JBoss at the time. And then I would take a dependency on JBoss, which would take a dependency on the JVM. And then I would just use yum install and sign the packages. So it was very similar to container images. Yes, there are some definitely differences about how you bundle things, but there was a concept of a package, there was a concept of a repository, and there's a concept of signing and checking these things. And then from there, instead of writing maybe Kubernetes configs, we were writing init scripts, and later on there were systemd unit files, or upstart was another init system people were using. And then you would take your package and your init file, and then that was enough to really get you to start the application. And back then, use something like Puppet, Chef, or Ansible to really describe the other dependencies that you need. And honestly, if you combine that with auto-scaling groups, most cloud providers, I work at GCP, but you can create auto-scaling groups that can do rolling updates, automatic service discovery and put in a load balancer. And for a lot of people, you can get 90% of what Kubernetes is doing for people with just virtual machines and great configuration management and using OS level packages, right? So I think these are some fundamentals that Kubernetes makes official and adds a lot more abstractions. But I think there's a way that you could do this in a way that will be, in my opinion, still considered cloud native.
Yes, definitely. And also, we see the first I see is serverless and the container was started. I see when the Docker is came into the picture, the PyCon conference is happening up, and I think Solomon Hikes they showed us a container, how the live container is working in the demo of the PyCon, I think, conference, and then people are thinking about the container, and everybody talking about that this is a different way that we used to think about it. So I think the missing piece from the industry is something called the container, and how the container you think how it changes the whole infrastructure, our thinking process of shipping our code from dev test to prod.
Well, for different people, Docker was very familiar already. If you were doing Heroku and you were creating build packs or slugs, this probably was familiar. If you were doing LXC, you were already kind of creating like these tarballs that you can bring in and out and treat as machine images. If you were doing like Go, like I was, then you were creating statically linked binaries. So you have an ELF binary that you just put on the server. So this concept of a self-contained artifact was a thing for a very long time. I think what Docker did was give you a really clean workflow, right? So instead of you having to figure this out with Jenkins or whatever build system you were using, you now had Docker that says, look, here's a Docker file. And again, I'm coming from the RPM world. I used to use a tool called mock, very similar. You create a chroot, you bring in all of your dependencies, and then you package up the results. So I think what Docker did was, number one, made it way easier to adopt that particular pattern. And then you get the container image where, let's remind ourselves, the container image is a tarball with metadata in it, right? And then you have this runtime that knows how to fetch it, extract it, and the layers was a really genius idea to make sure that we can deal with how big these things will get if you're dealing with, bringing in all of your dependencies into, all of the layers. So I think what Docker really did was take the trajectory we're kind of already on, LXC. If you use Packer from HashiCorp, right? People were using Packer to create VM instances. So that way, when you're in Amazon using things like auto scaling groups, you can just point to an AMI and have the OS, everything you need, including the app, just ready to go. So we had already started on this trajectory. I just think Docker came and just really gave us a really nice end-to-end experience for building, pushing, and running those images.
And also, I think the Docker people always talking about we evolutionize the container industry in a very similar way that everybody can work with containers. Before that is the job of the Linux kernel to give us the container, and then on top of that we can work it. But with the Docker and the daemon on the Docker side, abstract of it all the details of running the container, life management cycles, you can just work for your application and containerize it. So I think I talk with the Docker people. They are things we created that tool that is called creating container, but we are thinking how do we ship that to the production and how it's going to actually work, and we are really thinking about. And then we see came along the Kubernetes and other ecosystem is going on. But for the on this question is when we don't have Docker, how the Google internally run containers and what technologies it's using LXC kind of technologies or some other technologies.
No, it's basically the same set. I mean, a lot of people, if you were doing virtual private hosting, some people were using containers that way as well. So those system calls have been there for a long time. Google's looking at this, and we have our own runtime that will just remember when you're creating the process, you just need something to say, I want my own namespace for networking and mount or whatever. And then you also lock some other things down. So I think people were doing this for a long time. It's just that, they made it accessible. They made it easy to do and think about, because remember, System D was heading in this direction as well. If you've ever written a System D unit file, you have the ability to tap into things like namespaces and C groups, right? So you can say, hey, System D, I want to limit the memory, I want to limit the CPU, and I also want to have a dedicated namespace when you run this process. So I think these things were already kind of in trajectory. But again, I think what Docker did really well was just really focus on that user experience. So a little bit of user experience goes a long way of taking these ideas and making them very accessible. Like AIX and Solaris, those were operating systems that had been around for a long time. But some people really liked when Linux came out, adopted the good new user land. So now you have things like Bash and you have Vim, you have all these things that made Unix a little bit more approachable maybe than Solaris. Does that mean Linux invented Unix and everything else? You don't really have to go that far, but they still deserve credit by bringing usability. And that's really where I think Docker really shines.
Yes, definitely. I think now their actual motive is to unify the developer experience. They are working on developer experience right now. I think their past is going to be might be some other. They have some motive, but right now their current focus is to give a developer a friendly environment they can run their codes on. So, and now we start from the Docker side, and now we can jump into the container runtime as well. We see that there are plenty of container runtimes out there, but do you see, I think from the Kubernetes 1.19, 1.20 release, we see that Kubernetes is now going to be a very broadly major release that is deprecating the Docker DIMS, Docker D support, that Docker shim support, and industry taking about, we always thinking about from Docker to Kubernetes, what is happening there? Is Docker is going to be deprecated from Kubernetes? What happening there? Can you elaborate this on container runtime interfaces? How many of there are, and what happened in Kubernetes? I think 1.20 release.
Yeah, anyone can still use Docker if they want to. It's just that you don't have to do it the way we used to do it. So back when Kubernetes first started, Docker was just built in by default. It was just hard coded. So you have the agent that runs on the server called the kubelet. And there was really no clean abstraction between a pod manifest, so one or more containers plus volumes. And then Docker has an API. Docker didn't really necessarily have like a YAML state like Kubernetes does. So when you think about the relationship between the kubelet and Docker, it was already weird where Docker wanted to do a lot of the things that the Kubernetes agent wanted to do. And remember, Docker didn't understand pods, still doesn't. So in order to make that work, you have to do a little bit of tricks to start multiple containers and link them back together. That's more of a Kubernetes abstraction. Over time, starting maybe 4 or 5 years ago, we decided to make a clean interface. I was still at CoreOS at the time. And so we decided that we needed a container runtime interface so that, number one, we can actually talk about what the actual relationship is between a container runtime and the Kubernetes agent that runs on the node. And this is mainly probably kind of pushed forward by CoreOS wanting to bring Rocket System D support to be one of those container runtimes. Also, Red Hat has a lot of experience in container runtimes, so they also need to know what was going to be the contract. So 2 things happened. One is we define a clean contract, kind of based on gRPC, and then Docker is first class, so we just kind of build the shim inside of Kubernetes so that way we can have backwards compatibility. That's just responsible engineering. And we left the backwards compatibility for years. Like people should have known this was going to happen because we told everyone. And then we started to see the rest of the ecosystem mature. Number one, Docker did a really good job, right? There's container D, there's runc, and both of those components Docker relies on internally. So what does Kubernetes really, really need? Kubernetes really only needs container D. So it's not like, oh, we're deprecating Docker. We really never really used all of Docker in the first place, right? We've never used all of Docker's features in the first place. We've always had a kind of impedance mismatch between pods and containers. So with container D, now we all have a low-level common layer to pull images, unpack them, that meet the runtime interface requirements. So Red Hat has a different implementation. Other people like Firecracker, they have their own implementation. It's fine. So what that means now is that you do not need this additional container platform when you can just use container D and runc. So that's the way people should think about it. We never needed all of Docker in the first place, but Docker was the right idea in the beginning because it was most complete and had a lot of good APIs, but Docker's been refactored, and now we have the right small components that are necessary for Kubernetes.
Yes, definitely. I think what the Docker team initially then is started this movement of modernizing your traditional app into the microservices architecture. They already Docker in its itself is a traditional is a huge app that everything built on top of it, and then they organize their module like container D, runc, and then donated the container D to the open source community like CNCF, and they did a tremendous job. And that right now I think we need just container D to spun up a container, pull the container images, and these kind of stuff. But to build the container image, you still need Docker as a developer, and developer you need something to build your containerize your application. So Docker is.
Well, you don't necessarily need Docker. Docker is probably still one of the best ways to do it. This is very true. But I think Red Hat now has tools that would just let you build Docker containers without Docker being installed. You also have other build tools that have now learned how to build Docker images again without Docker being installed. So I still think the Docker file, the way Docker does everything all in one package, is really nice. Fully integrated end-to-end experience is really nice. But I think now we're talking about OCI images, open container images. And these container images are what Docker supports. Thank you, Docker, for doing all of the hard work, giving us a specification. But I think right now we can probably think more of things are OCI compliant, and now multiple tools can produce, build, fetch, pull OCI images. So I think now when you say Docker images, I think that's, because that's where it came from. But I think we all are technically now implementing the OCI standard versus purely the Docker standard.
Yes, definitely. I think Google and also have some kind of their own mechanism of you don't need to run anything. It's abstracted away with all the container detail from you and pop up the container on top of it, and you don't see what's happening under the hood. At the end of the day, you pop up a container on top of it. I see the tweets from the Google's team developers. They did I think I don't build kit, some other kind of tool they have to doing these kind of steps. You don't need to understand what's happening under the hood, and I think that's where the industry is moving right now. And also on top of the container runtime interface, and now we just try to jump on the networking side as well. And on the topic of these CRI and CNI, do the Kubernetes previous, what is I think is used to call as Borg or a Mega, do they have the same kind of interface like container runtime interface, container network interface, and container storage interface? But we try to understand what the container network interface and what are the, I think, the possible solution. We have Cilium, Calico, Romana, what these are moving, you think where it's gonna moving in this year and moving forward?
Yeah, I think Borg is just a whole different system where, we have different integrations, right? We can integrate with custom hardware that doesn't exist on the outside world. So we can do hyper optimizations because it's kind of only one real customer for Borg, you know what I mean? In terms of people building on it. So do you need the same extension points? Probably not. So there's a collection of things that come together to make Borg, right? if you think about Borg, there's something like Istio we have for networking and policy management at that layer. So it's not really about like Kubernetes being a one-to-one to just Borg. You're really thinking about a collection of things. So you would really have to start thinking like Kubernetes plus Istio plus Prometheus plus some MapReduce tooling plus. So there's so many more things that make up a full orchestration platform like Borg. So I think as Kubernetes is kind of one layer, and you need all kind of layers to make this work. So I know people wish like, oh, we want to use the exact same thing. The truth is you probably don't want to use the exact same thing. It probably wouldn't work the way you think, and it's highly opinionated. So you would probably have to change the way your apps work if you want it to work that way. So I think Kubernetes, OCI images, they're a little bit more general purpose. They need some more integration work. And then if people keep at it, it's going to be super powerful on its own.
Yes, definitely. I think one of the best advantage that the Kubernetes as a community providing us, they don't reinvent the wheel in yourself. They ask the community to build out these solutions like networking solution like Cilium, Project Calico, Romana, and also they ask the community to build that tool so we can integrate your tool with it. In that way, the business also grow and the open source community also thrive. At the end of the day, everyone take advantage of each other. And also in the storage space, like the Kubernetes storage space, they also have a container storage interface. And that is also moving the same way. Somebody else building that tools and Kubernetes just integrate with that. And I think that is the best way to drive the business as well.
It might. You got to remember, everyone thinks they want modularity. It's kind of nice, right? You can say, oh, I can take this storage plugin, I take this networking one, and everyone kind of has something different. This is great. This is powerful. I'm glad Kubernetes works this way. But that's a lot of complexity. Over time, sometimes this gets so complex that a new system will come around that merges these layers to something more simple. And this happens time and time again. So everyone says, oh, we want freedom to do anything. And then later on, they say, oh, it's so complex. Why do I need 25 components to have a single system? And the next system that will come will probably have all of these things built in by default and start there. And then people will say, oh, that one is much easier than that one. And there's an opportunity there to say, hey, we've learned a lot from the old way, because you got to remember, Kubernetes is replacing some things. We have to make sure that we understand that something will probably come around to replace Kubernetes. And we may look back at this time period to say, maybe one of the downsides was that it became so modular and we stayed there so long that instead of improving the system as a whole, maybe we spent too much time on plugins, 500 load balancers, 500 storage drivers. There's a cost to that, and it's called complexity.
Yes, definitely. That's a point that is everybody concerning about. And you did a very good, you raised a very good point. And all the genius like you raising this point of the complexity, who is going to manage the complexity? Because at the end of the day, we love Kubernetes because it removes away the complexity before we have. And now we have just one complexity, that is to understand the Kubernetes and to work the Kubernetes in an efficient way. So, and now we are doing the 500, like as you said, 500 storage provider, 500 network provider. You're bringing in the more complexity of learning these tools and integrating these tools. So that's a very good point that you raised, actually. So now we try to jump on the distro side of Kubernetes. How you compare Linux distros and Kubernetes distros with it. I always try to compare with this, but I know that there is a huge distinguishes between these two things. But I think when the Linux came up, there are so many distros called Fedora, Red Hat, so many distros, OpenSUSE, SUSE, and so many. And at the same time, the Kubernetes came up, the K3s, K0s, Micro K8s, and you can name it. So what the distros are and how it's going to be, how it came into being.
Well, you need a distro at this point, because if you think about just pure upstream Kubernetes, these days the cloud provider integration is a separate thing. Different network plugins are a separate thing. We don't build them all in anymore. So what happens is, number one, you need infrastructure. You need a hypervisor with some APIs. You need some infrastructure as a service APIs to be mounting storage, to be creating load balancers. Kubernetes doesn't do those. So once you have those APIs, then you need implementation. So when you think about it, if you go to Amazon, you're going to have EKS, which is going to be Kubernetes plus cloud provider integration and plus any other provisioning tools to make it actually work. Same thing for like a Linux distro, right? Like if you just go get the Linux kernel without a shell, it ain't going to be usable, right? So you need the rest of it. And then when you think about a Linux distro, there's also installation tools, right? You can have Kickstart or Pre-Seed. These things will help you kind of lay down the image, pick some packages, give you an installer, do some patching. The same thing is true when you think about the GKE control plane. So a lot of people think, oh, I just go to GitHub, get the Kubernetes and binaries, and then you're done. No, you're going to have to bring in, what do you want to use for metrics? You want to use Prometheus? What are you going to use for logging? What are you going to use for IaaS? How are you going to do a service account and IAM integration? So you still have to make all those decisions. So when you hear things like Anthos or K3s or any of these distributions, they're all making some decisions, doing the integration work. And so when you do deploy it, you can actually use Kubernetes to do all the things to run your application. So we're in the distro era because someone has to do that integration. And the ones that we haven't named, these are the ones that people are just rolling themselves. You know, they go and get some VMs, they install Kubernetes, and then they start adding a bunch of things to make it their own distribution. And that's okay too. So I think we're still early, but I think we're firmly in the distro era of Kubernetes.
Yes, definitely. I think the point that I would try to drive home here is that the Kubernetes came out with the container runtime interfaces, storage, networking, whole these kind of idea. And somebody has these packages built in. Let's say you want to run the Kubernetes in a fastest way. K3s has some integration of, let's say, it's a Kubernetes monolith. It's a fastest Kubernetes monolith that has the storage provider. Also, they have a network interface. Also, has a container runtime, and that they spun up in a 2 or 3 minutes. And when you install the Kubernetes yourself, this might take the whole day of configuring the cluster, and then provide the extension point to bridge the gap between the storage interface and network interface. So I think that is the whole point of the distros right now. So it's make your life easier by deploying the Kubernetes cluster in a 2 or 3 or 30 second, might be 2 minutes, 2 to 3 minutes, or might be 30 seconds. It's a lot faster than. And there are so many, I think, come up, and hopefully there is so many come up in the future as well.
But you're also making trade-offs, right? So if you take like, you know, one of those where it's just like a single binary, maybe you want to do it for some embedded device, or maybe you're in a store where you want a Kubernetes cluster, but you don't need a huge footprint. Maybe that's the right trade-off. But if you're in an environment where you might have 5,000 nodes, that may not be the right trade-off, right? So I think this is why you need these distros, just like Linux, right? Android in many ways is a distribution of Linux for mobile devices. Very different than maybe Red Hat Enterprise Linux that you will run in the cloud for your servers.
Yes, definitely. And so on the topic of the next point, that I think we all see, that's a Rancher Kubernetes engine, Kubernetes KKP platform. And these platforms also came up. And I try to understand what it is and why it is they popping up, and what the problem they try to solve. Can you elaborate this? Because I never understand what's happening in that area.
Well, I mean, it's like restaurants, right? You know, maybe we can just all eat at McDonald's. So why do we have Italian restaurant? Why do we have Chipotle? Why do we have all these restaurants? It's because of opportunity, right? People have different styles. People have different needs. You may specialize in a particular market segment. Maybe you want to optimize for finance. Maybe you want to optimize for embedded. So I think what happens is, you know, we have really good tools, right? Like to create a Kubernetes distribution, you can do one fairly quickly, right? You know what needs to happen. We have a lot of great automation tools. You can almost go get Terraform, pick a few components, put them all together, and then you're on your way to having a Kubernetes distribution. So number one, it's relatively straightforward to start creating a Kubernetes distribution. Like, I don't know if you remember, I used to watch this site called DistroWatch. There's like hundreds of Linux distributions. And they all say, pick this one if you're doing graphics work. Pick this one if you're doing video editing. So you typically have people who want to cater to a subset of the broader community and really focus. And that's where the opportunity comes from, because they'll make more decisions. So then some people will say, hey, look, I can go get the generic one, or I can go get something like, I don't know, OpenShift from Red Hat, where they put more layers on top to give me some kind of experience that I won't get by default. So that's why I think you see a lot of these, is because there's opportunity still.
Yes, definitely. That the first point that we try to raise here, that Kubernetes asks community to do some kind of stuff they want to do. So if they want Kubernetes in a particular way, build that tool for the community. So at the end of the day, business thrive, open source thrive, but there is a pros and cons to every relationship when you try to do this kind of stuff as well. And I think the next question we try to do, I think Docker Swarm is out of story right now with the comment comparing to the Kubernetes. But I try to ask this question, that when the Docker Swarm came up, we have a battle of Kubernetes and Docker, and it's a very strong battle between them. There's some features coming in the Docker Swarm, then Kubernetes injecting, and there's a very strong comparative strong battleship between these two orchestrator. Then we, after 3 years, Docker Swarm is way out of the picture, and Mirantis has acquired him, and nobody knows what happening to the Docker Swarm. But you also try to elaborate on this, how the Nomad is compared to the Kubernetes, because Nomad is already in the scenes and they have built a very good community out of it.
Yes, I think when people try to compare them, you can always compare and say, hey, this one has this features, this one has those features. When you look at the open source communities, the good news is you can just learn from each other. Hey, look at that feature they did. That's pretty nice. Maybe we should implement it in this community. And on the engineering level, the technical level, you probably want different ways of trying to solve a problem, so we can all experiment differently. And then if you're mature, then you share features or you learn from each other. Now, when people really talk about like Docker, Swarm versus Kubernetes from the business perspective, that's where it gets a bit tricky. If you want to build a business on Docker Swarm and you want to build $1 billion business, there may not be $1 billion worth of revenue for Docker Swarm, given that the industry has kind of standardized on Kubernetes, all the major cloud providers, all the other players. So then you look at it from a business perspective, you may say it doesn't make a lot of sense to have a large team and building a business around Docker Swarm if you believe the market isn't there. But that to me should be considered separate from, should Docker Swarm even exist, right? There's going to be an open source community. Some people may like that it's simple. Some people may like the way it works. And if that's true, then we should find a way to make sure that those people can continue to contribute and keep the project going. So I think we always got to be careful. Let's decouple, the different open source projects and communities that are trying to solve a similar problem in a different way. There's room for, you can have 100 of those. Now at the business side, that gets a bit tricky, because the ecosystem, the support, the knowledge, that's going to dictate how likely it is to have a sustainable business, which is different than a sustainable project.
Yes, definitely. And can you try to compare what the Nomad and Kubernetes feature and what's they going to be comparing with? Because I think they are both right now in the hot market, and I think Nomad has some kind of community right now, but definitely is not same as a Kubernetes community. But I think they try to do some extra, some those things that are that's doing some kind of spinning up the cluster of 1,000 nodes of a cluster in 2 or 3 minutes. They're doing things in a faster way. The Kubernetes is quite slow because of this whole feature set and all the. They try to things in a very fastest way that I have heard about it. What do you think? How these compare and what their communities are?
Yeah, I think Nomad optimized for very fast scheduling. They talked about a lot of the white papers they implement to optimize for scheduling decisions. And there's some value with that, right? I think there's some people who like that for maybe doing things like a CI job, or, in reality, do you really need to optimize on that? Who knows, right? Because there's so many people running Kubernetes in production doing large scale things. So, is that a good place to optimize? They chose that direction. Nomad also did some really nice things around user experience, trying to have a very simple install, single binary. They did things outside of containers. They support binaries. They support Java. So they have some kind of unique stances on the way they look at things. I think Kubernetes is like a bigger ecosystem. We have way more extension points in the Kubernetes world, right? We have an extension point for building new resource definitions, right? I think that's a real key distinction in Kubernetes, is that it's just not Kubernetes and then that's all you get and then new features will come. You can extend Kubernetes in a very first class way. And that's what made Kubernetes very different from an infrastructure tool, that if you want a new abstraction, you can create it and get all the value from the API server, RBAC, all of these things will automatically be generated from you. And you can extend it to do new things like Istio and build all kind of new control planes. So if you think about Kubernetes, it's almost a universal control plane. And we happen to ship a distributed system for managing applications. But now you have something that's way more powerful that can build any abstraction, right? So you have things like config connector and crossplane. These things feel like a modern version of Terraform. You have Istio doing service mesh. So you have so many use cases for Kubernetes that I think that the ecosystem is really where I think it became an industry standard. And this is why all the major cloud providers have a managed service. But Nomad doesn't mean that they've lost anything. It's just they optimize to be a tool with a specific purpose versus being a generic extension platform.
Yes, definitely. I think the HashiCorp, the co-founder for Armand Todgor and Michelle Hashimoto, I think they have a concept of the developer life experience, software, what the software development life cycle is. So they try to develop dev tools around it, then virtual machine packet and other kind of thing. So I think they move in that way of software development life cycle, and then the things, if that tool doesn't exist, they try to put an effort on top of it and try to build that tool as well. I think they're moving in a very good direction as well.
Yeah, but just to be fair to HashiCorp, if you look at a lot of their announcements, they have Kubernetes support.
Yeah.
They're building native Kubernetes support. So I think for them, they're kind of pragmatic. The industry seems to really, really like Kubernetes. They're going to make sure Vault, they're going to make sure Console, all of their tooling works well for Kubernetes and Nomad. So I like the way that they're approaching it. You don't have to have just one thing. And if it doesn't work, then that's it. They can look at the collection of their components and say, look, we build things that work well together. But if our components can work well with another ecosystem, they do it.
Yes, definitely. I think the word to use, that's a perfect word to use with the HashiCorp team, the pragmatism, that they use these kind of thing they have a pragmatic culture, I think they have inside their company. So before we jump into the cloud world, or the AKS or the EKS or the GKE world, so now try to do some the service mesh magic, try to discuss with you. I think we started from the Istio, then we have a Linkerd, then we have a console from the HashiCorp, and now I don't remember the names of ton of them because I think 20 of them is already in the map. So can you try to introduce this story of service mesh in general, and do this kind of approach exist in Borg or Omega kind of system as well?
So I think, if you've been doing this for a while, even 15 years ago, a lot of people were using something like Nginx to handle a lot of features for applications. And if you used JBoss before, you also had a kind of somewhat of a proxy that sat between your business logic and the outside world. And you could do things like rate limiting, you can do TLS mutual auth. A lot of these features you could do in some of these other tools already. I think when people start to think about where do you put the proxy, right? Some people will say, hey, putting the proxy in front of every application is new. But then if you think about PHP, almost every app was inside of a proxy like Apache, right? The LAMP stack. So that's also familiar to a lot of people. So I think we start to talk about the service mesh, maybe now that it's cloud and people have been thinking about microservices, they're using new terms to explain some similar things. And we have much better automation tools. And we also have an orchestrator like Kubernetes to bring it all together. So when you say service mesh, you have a control plane, and you have data plane. And if you're used to Nginx, the control plane for most people was the Nginx config file. You put everything in there, you copy it to all the servers, and then you hot reload Nginx, and then you get the new configuration. So I think what Service Mesh does is a more explicit to say, hey, let's move all this configuration to a server. Let's also integrate with the orchestration layer that is starting the application and giving the application identity. So now you're being more service oriented. Now you're saying when the app comes up, I'm going to give it an identity, and then that identity I can use to give configuration dynamically. This is like the big change, I think. But the fundamentals of, you get this TLS certificate, and you get this JOT token, and these are your rate limiting rules. Those are familiar. People know about those. But I think what's new here is the full integration to the infrastructure, the identity, and then automation around all of those things. So internally, Google does and has for a very long time had a service layer infrastructure that says an application has an identity, and when apps talk to each other, we use kind of this proxy concept so you can put all the logic, because at Google, you have people that are writing C++, Java, Go, maybe some Python, and you don't want to implement all of this kind of security logic in every runtime and language. So sometimes this pattern of a sidecar, put it next to the application or put it on the host and let all the applications use it either way. This is a very nice pattern to bring a lot of capabilities. But again, if you think about it, these are the same fundamentals as like some of the things you could do with Nginx and some of the things people were doing with things like JBoss. But now I think we just have better tools and control planes to make it work.
Yes, definitely. And I think the concept of the pod in the Kubernetes is one of the best things that in the Kubernetes provider. They give us a pod, and inside pod you can run more than one containers. At the end of the day, the logic that you've written in previous application for the canary rollout or dock launch deployment or the circuit breaker patterns, they're now written inside the sidecar. Now your application code is quite be shrinking again, and you can do these kind of the circuit breaker pattern or all these kind of things inside the sidecar. And the sidecar is at the end of the day, you're doing canary rollout or dock launch deployment in the network layer, regardless in the configuration code. And I think that's the best thing with the Kubernetes is a part of the pod itself. So on the topic of the service mesh, the one new question pop up is,
okay.
On the topic of service mesh, I think you see the whole ecosystem that is, first up, SMI is come up, and you see service mesh interface like the container runtime interface, network interface. Why not we have another interface called a service mesh interface? So once Istio is going to be going to the open usage common. That's a new, I think, the community that is holding the Angular side of the other Google internal projects and open sources and open usage common are you maintaining or moderating these projects. And I think now on the CNCF landscape, everyone is looking for the Linkerd, but Linkerd has some limited number of functionality. So can you draw some point where the community, where the people are going, move forward in the service mesh ecosystem?
I think it's going to come down to ecosystem. If you look at all the major cloud providers, or many of the major cloud providers, Envoy is at the center of this story from a data plane perspective. So, what control plane you pick can be separate. For example, in Google Cloud, we have Anthos Service Mesh, we have Traffic Director. Amazon also has their own kind of service mesh, but the commonality is Envoy and the XDS configuration protocol. So in that ecosystem, some people will just use Envoy as a standalone gateway and just use the Envoy config file. It works just fine. You may want to bring a control plane like Titrate. There's a startup that does this. They have a nice control plane to manage multiple clusters. You're going to have a lot of people in the ecosystem that will try to remember there's opportunity. What features do you want to bring? What UI? What's the workflow? So I think there's a kind of, you also have Nginx, right? I think they have Puma, they have their own thing. Console, we just talked about HashiCorp. They can use console as a control plane to do a service mesh. And they support different implementations, right? I think they support Envoy, and they also have a library that you can import into your app to do some native things. gRPC, right? So even without Envoy, gRPC, the framework for doing kind of remote procedure calls between different languages and apps, can also talk to SDS control plane to get configuration, just like Envoy does. It doesn't do everything, but it can be configured this way. So this pattern makes a lot of sense. Now, Linkerd, remember, Linkerd has been doing this for a while, right? I think it was called something else before. It was Finagle or another framework. But this concept of having a central networking device on the machine and everything going through it is what Linkerd has been known for. What I think they're optimizing for is a little bit more like simplicity out of the box, have a lot of the key things you need without learning too much complexity. And honestly, they might be making a good choice. We'll see that they're decoupling from the runtime, right? They don't necessarily need a Kubernetes. They can run well on a VM. They support different configurations. So I think the community will decide which one is good. But again, there's nothing to win because I think there's like not a zero-sum game, but I think they have approaches. But the fundamentals, control plane, data plane, and functionality.
Yes, definitely. So I think we cover a lot of the Kubernetes with the service mesh ecosystem. Now let's straight go to the cloud world. And I think that's a topic of interest to everyone because Azure recently announced the Azure Arc, the AKS for AKS kind of thing. On top of it, GKE is also announces the GKE Autopilot. Amazon is also on the competition side. They've done a tremendous job of making their own Kubernetes distro like EKSD. So there is so much happening going on, and the only person that give me the analyst overview, a 360 degree overview, and that's Kelsey. So can you introduce these three innovations that is happening in the cloud, major public cloud?
Yeah, so I think Arc is, I kind of look Arc more like Terraformish type of thing to configure resources across multiple providers. They also have some implementations, like Microsoft has been doing software that runs in multiple environments forever. You can run Microsoft SQL Server in multiple environments. Many cloud providers do. Windows runs in all the environments. So they know what they're doing in this area. And I think, remember, we talked about this control plane. So for them, they're saying, hey, we need to have a control plane. And it reminds me a lot of like Terraform. Maybe they'll go with a different style. Maybe they'll have different integrations, maybe some linkage to Azure. So it makes sense. Like, look, that's what Arc is to me. They're going to expand their control plane capabilities to be able to manage additional resources in the other providers. Now that all of the providers have really nice APIs. And sometimes you could just even use a Kubernetes object to describe those other objects in other places. And crossplane.io also does this CNCF project that's open source. So that's Arc. And then you have, Amazon has their Kubernetes offering, EKS. And when it came out, it's really nice, right? You have a control plane, they hide it, and then you can bring your own nodes, right? So you can create some node pool or auto scaling group, attach it to that Kubernetes. Weaveworks has a nice command line tool. I think it's like EKSCTL that will help you kind of create the other part of the cluster. And then in Amazon, you also have Fargate, which is saying, now they made some trade-offs because while EKS gives you the full Kubernetes API, jobs, stateful sets, daemon sets, deployments, etc., Fargate is a little not the full API, right? So you still kind of have some Kubernetes thing. You can give it like a pod. There's some objects that work similar, but there are some objects that are not supported. I don't think anyone would say that's Kubernetes. It's based on Kubernetes, but it's not Kubernetes. So then you go to the Google side of GKE. So before we get to Autopilot, when you say GKE, so GKE is like, hey, we have control plane and we manage the worker nodes. So typically you won't be going to find a different tool to manage it. And to be fair, AKS from Amazon or Azure is very similar, right? We both kind of manage the control plane and the nodes together. I think all three of us have done a good job of integrating our capabilities from networking. You have E&I in Amazon, Google, we have IP aliases, and this is all to make networking way more efficient. So we're all doing a good job there. We're trying to make that work. So I think for us on the Google side, we wanted to apply the serverless operational model to Kubernetes and GKE without making the same trade-offs that Fargate did. How do we give people pretty much the same Kubernetes API, just so people know? Autopilot is the same product with a different configuration. So it's the same Kubernetes API we've been running for years in production. This is not some new Kubernetes. This is not like a new K3s. It's none of those things. It's taking GKE and turning on all of the security. Do not let people run this privileged. Lock down the certificate API so you can't make a certificate. Hide the nodes and we manage it. So we also gave a new pricing model, very similar to like Fargate, again, without the API trade-off. So if you give us your deployment, or you give us your stateful set, or you give us some other object, we then look at the memory requirements and we create the nodes behind the scene automatically. We can scale them horizontally and we charge you for the pod. So we're basically taking full Kubernetes, making the infrastructure kind of be hidden. We take care of all the ops of clusters and you just kind of focus on your Kubernetes objects, right? And then that's kind of the lay of the land of where we all are in terms of how we're thinking about, taking Kubernetes to the next level.
Yes, definitely. So what I see in the JKE Autopilot, before that, the GKE, we abstracted away the control plane, and now we're managing the nodes to run our applications on. But the GKE Autopilot, that's also abstracted away the control plane and the node along with it. We charge with just the pod that is running on the node, and everything abstracted away from us. So it's I think that's the difference between JKE and GKE Autopilot. It's abstracted the whole Kubernetes, how they work, and you just written the application logic. And for to run your application, you need a pod. And when the pod you need some kind of computing. And for that computing, GKE Autopilot some charges you some money and these kind of stuff. And
that's right. We try to take care of auto scaling and all of these things. So even if you have GKE, even though we have nice tools to manage the node pool, you still have to think about them. You still need to configure auto scaling. Even though we had auto scaling, you're still kind of responsible for making it either too big or too small or figuring out what's just right. Autopilot says, let us take all of that responsibility. Plus, we need a configuration that's really supportable. So we got to take care of security. And we got to have right default options. That means we can cleanly upgrade. We can do all the nice things because we know you have a really, really strong configuration.
Yes, definitely. And before, I think the next question on the GitOps side as well. And you try to understand what the GitOps is, the models, practices, how it's originated, what purpose present of GitOps. And also try to answer this question, which cloud provider is going to target the GitOps? Either it's going to be Azure. I see Azure with the Azure Arc has some kind of a GitOps capabilities. I don't know as of today what the Amazon did for the GitOps side in the AWS. Do GKE some kind of GitOps things in it? I don't check it, but you can understand, elaborate this on.
Yeah, I mean, GitOps means everything at this point to people. So I don't, look, you can write declarative configuration files. You can check them into a repository. You can check them out of a repository. You can apply it to some clusters. Now, there's different tools to help you do that. You can call that GitOps if you want, I guess. But I think the GitOps philosophy is around, can we version our configs? Can we kind of put more structure around them and then apply from this kind of model? And Git dictates some type of workflow, right? You can do pull requests, you can do branches, you can do tags. So when people say GitOps, it's more like bringing the Git workflow to operations. It doesn't work for everything though. This is where I think people have to understand. If you're just talking about just pure Git, meaning you check in all your changes and then cut a release, this doesn't work if you're going to try to roll out software across multiple clusters over 10-day period. How would you even articulate that in GitOps? It doesn't make a lot of sense, right? So maybe you create some more tools like Flagger that says, take this repository and roll it out over 7 days. Okay, so that's one way of doing it. So you need some additional tooling above just Git to make all of this work. So I think GitOps maybe is not doing, it's not the perfect word to describe what we're doing. Like serverless isn't perfect, but I think GitOps is trying to say, instead of just running commands like, shell scripts or even Puppet against infrastructure live, this is saying, check in your desired state and then use some tools, whether it's manually checking out or CI/CD. Some people are now using tools on the Google side. So you asked about what Google is doing for GitOps. We have a tool called Config Sync. The commercial version of that is going to be Anthos Config Management. But the way Config Sync works is there's two ways. One is you can just take all your Kubernetes objects, put them in a repository. When you install Config Sync, it just watches a branch or a repository, and it pulls in the changes and applies them to the cluster by being really smart about how it merges things. And then you can go in advanced mode where you can have a cluster hierarchy. You can say these clusters get these configs and these clusters get those configs. So you can have a little bit more rules, and then you can choose how you work. Either you can check in things manually, or other tools can be generating objects and check in, and then this tool will eventually be watching and pull. So to me, GitOps is more of a workflow based on declarative configs, but we have to be careful because it doesn't work for everything, right? Let's say you have an autoscaler for your pod and you check in your deployment configs. You may leave the replica field out because you don't want GitOps applying just three, because the autoscaler may say sometime it will be 10, sometimes it will be 5. So what you may do is check in the deployment with no replica field, empty, because you don't own it. And then you may have an HPA that says minimum 2, maximum 5. And then when you deploy, those two independent controllers will take over and change the live replica field to match the policy. But if you look in your Git repo, it will not match. The field on the deployment will not match what you have checked in because you don't own that field. So there's still some work in the GitOps workflow to understand ownership, because sometimes things are generated live in the cluster that never will be reflected inside your repository. Like if you use Knative, when you give a Knative service is going to create deployment, Istio configs, config maps. It's going to create a lot of other objects. Do you check those in too? Or do you say that Knative owns those objects and you only check in your Knative objects knowing that it will create child objects? So we got to make sure that we're thinking clearly about what GitOps actually does and the trade-offs.
Yes, definitely. I think the dude was a very good point that right now people are building the GitOps tool, but we are lacking the GitOps working flow. How the final working GitOps flow look like. Without understanding and kept in the mind, everybody on board what the final flow look like in the GitOps world. Everybody is looking for the tools. We have Argo tools, we have Flux, we have CodeFresh. Also, they made some tools in it, but we lack the as you said that, because I also think about the good we have tools available, but we are lacking how the GitOps flow is work. So this is a very good point that we need to understand what the final flow is going to be look like for every application in the GitOps. And that's why I think the GitOps working group is created for that. And I think they did some kind of a meetings on monthly or weekly to try to understand. But I think this is a very hot topic coming up in the 2021 and moving forward as well. So now the last, I think for the final few topics, with the serverless, and that's I think the interest of Kelsey right now. Can you introduce what the serverless is and how it's originated and what its aims are?
Yeah, I think Amazon gets credit for the word serverless. I think Amazon also gets credit for the criteria in which we measure serverless. So some people would say it's an operational model. meaning when you're not using something, you have the option of scaling down. Some people will say serverless also has a billing model. You pay for what you use. So in the Autopilot, GKE Autopilot, you pay for the pod, not the cluster. So then that makes GKE Autopilot more serverless than GKE. So that makes a lot of sense. So you have an operational model and you have this pricing model. So you have this philosophy around applying those things to anything. So for a database, right, if you're not using, you don't pay for the database. When you are using, you pay. And so that gives us this ability to say, where else can we apply serverless? Now, there's other people that say serverless has to be functions. Some people say if it's not functions and an event, then it's not serverless. And I think Amazon kind of cleared that up a couple of re-events ago. They said serverless is a spectrum. Now they have serverless Aurora. They have serverless things. They're calling Fargate serverless. So that means I think we all now have permission to look at serverless beyond functions. So now what is serverless? So in my world, I love containers. We've been talking about containers this whole time. Packaging the application with all your dependencies. This is a good contract for the developer. And so with that, if you combine it with a little bit more configuration, you have enough to tell the platform how to run the container. So now I can give you something like Cloud Run that says, don't worry about clusters, don't worry about Istio, don't worry about any of these things. We have the ability to shape traffic based on the different versions. You can integrate with Google Secrets. We can scale to 0, or we have a feature called minimum instances. If you don't want to scale to 0 and you want to avoid cold starts, you can do something like that as well. And so I think what we're saying now is let's take containers and then give people all of the, like, how would you run it globally? How would you do all of the things that I can piece together on my own if I had Kubernetes? What could you do for me instead? So I think serverless, this philosophy, can we build lots of platforms that are focused on workflows? So there's not going to be one serverless compute. People are like, oh, it's just going to be Lambda and that will be it. No, you're going to have Lambda, you're going to have Cloud Run, you're going to have something like Heroku. I think that's where we're going with serverless.
Yes, definitely. I think I used to think as a serverless like when you write a code in the Visual Studio, you have a snippet called tap tap, and it's auto-complete your code, and you have a very slow time of moving that tab. I see serverless in the same way. It's a snippet that creates the infrastructure for you, and now you are just concerning about the application that is running on that infrastructure. And in that way, there's a very fastest way for you to run your code, test your code, and test your code in a production setup. And that's where I think industry is going to be moving. The whole IT is going to be moving, because at the end of the day, it saves you a lot of money. And who doesn't want that? That's the end of the, I think, goal is.
Yeah, I think people are used to it. You know, they just don't know if it's going to come to their domain, but there is opportunity for it to come to their domain. You could run your own email server. You can use Postfix or some other tool, or you can get a Gmail account. You click, you pick a username, and then all of the features are there. Upgrades are automatic, and you don't run a server. Same thing for like DNS. You register a domain name, you put in your rules, and then the DNS server does all the right things it needs to do. So why not have that convenience for our databases, for our networking, for our compute?
Yes, definitely. So we travel of 3 degrees, 6 degree our container to Kubernetes to service meshes to GitOps to serverless. I think we cover a lot. But next question is for the youngster who want to learn Kubernetes. Can you give some points on how they learn Kubernetes? Because at the end of the day, these are the topics are not going to be educated on the universities, because Kubernetes came out of 2014. And without, when somebody is graduated in 2014, they never heard about Kubernetes. But after they graduated from the university after 7 years, now they think you need to learn Kubernetes. So can you elaborate to our listener, to my community, how they learn Kubernetes, wow, they feel passionate about it, and why it is important for them to learn these container Kubernetes stuff?
I mean, I think it's important right now because it is an industry standard. So a lot of times if you want to work in this industry, it is helpful to know what the industry standards are so you can bring some value to people who hire you. So those skills are going to have jobs, and there's a lot of people hiring for these skills. So if you're coming out of university and you want to kind of start placing bets on different skills, right? You can pick a programming language. Maybe you pick Golang, maybe you pick Java. But either one you pick, there's going to be a set of job opportunities that come from that choice. This container thing is starting to become high demand because we're starting to see the industry standardize. So maybe Kubernetes isn't the first one you have to learn, but I think it's healthy to learn about containerization, maybe learn a little bit about the history, learn how Docker works, learn how things like Lambda, maybe even Cloud Run or Heroku, get a feel for those things. And then understand why Kubernetes still exists, even though we have those things, because there's going to be more complicated things you want to express. Like if you're doing TensorFlow machine learning jobs, you may need more features that Kubernetes has to offer. So I would say maybe you're going to be tempted to try to figure out how to install Kubernetes and configure everything. Look, that's good to know too. I wrote a guide called Kubernetes the Hard Way. If you really want to kind of learn about that stuff, that might be one place to look. Kubernetes.io has a lot of stuff as well. But I think I would recommend people really learn the Kubernetes API. So maybe go get something like K3s, just put it on your laptop. Don't worry about having 5, 10 different nodes. Just get a feel for writing applications and then making them run inside of Kubernetes. I think if you learn that part, you will have the fundamental skills to say, look, if I want something that can make sure my app is running, make sure that it's configured properly, and has access to the broader ecosystem that the industry is standardizing on, that would be my approach to learning Kubernetes. But you don't have to learn only Kubernetes.
Yes, definitely. I think when I started my career in 2016, it's the first time I was moving in the company, I see people write code in .NET code, Java, and these kind of stuff. Then they package that up. There is some you need to learn how the Apache Tomcat is going to work is order to apply your application on top of it. You also have to learn the Heroku and these kind of stuff. I'm also confusing how the Google is going to do that because they have a humongous employers and humongous infrastructure and these kind of stuff. So I try to think if we have a tool that the whole company is going to be characterized by one single tool, and I think that's the Kubernetes is the best thing at. The whole company can set your infrastructure in the Kubernetes, and every developer can talk to the Kubernetes and deploy the application on top of it. And that's, I think, beauty of the containerized application, cloud native world, and Kubernetes. That at the end of the day, from hiring manager to the CTO to the company and the developer to the ops team, everybody talking about Kubernetes cluster, and that's a primary language inside the company that everybody is using. So I think that's a goal of the Kubernetes as well. So I try to join you again in future, but really appreciate it. I think it's been a pleasure. It's been a pleasure talking to you. I'm looking forward to that. I think we have met in a very tremendous, best time in the, I think, IT. We have talked about the Kubernetes. There is so much happening. We are talking about in the moment that serverless is going to be the topic of everyone. GitOps is a topic to everyone. So I think there is so many points that I've talked to you, and you really amaze me with the knowledge that you have. And for the last few pointer, how you collect that knowledge. I think if I ask you any question on any IT infrastructure related, either on the AI or the machine learning, on the developer, on the everything, I think you know everything a lot. How you capture these knowledge information? Can you give us some points if we want to follow suit you?
Yeah, I tend to focus on the fundamentals. So when I see something new, I always ask, where did this come from? Right. So if I see Envoy and I look at the features, mutual TLS off, rate limiting, you see all of these kind of features, and I say, okay, what would you do if you didn't have Envoy? And of course, I have a lot of experience, so it's easy for me to draw on previous experience because I used to write a lot of code. I used to deploy code. I've had all of these jobs before. So over time, you start to see the same patterns come back around. Of course, a lot of times it gets better. I'm not saying they're all the same. So anytime something new comes out, I don't think about, hey, how do I start over and just learn Kubernetes? When I saw Kubernetes, I said, it has config, it's declarative, there's a control loop. That sounds like promise theory. And that's what I was doing when I was working at Puppet Labs. the concepts are so similar. So once I have the fundamentals, then I'm more confident to just really learn how they're approaching. I think sometimes if you don't understand the fundamentals of like promise theory, configuration, how a scheduler works, how container works, when you look at Kubernetes, you're going to say, oh, it's so complicated, it's so confusing, there's no way I can understand it all. I don't know if you can just start from there. I think you have to look at the scheduler and say, why are there schedulers? Are there any other schedulers? Oh, there are. Okay, so now I think I understand schedulers. And it's okay to take your time. People think that you're going to learn this stuff in like 3 days. You don't have to learn in 3 days. Sometimes it may take me 3 months to really learn. Like when I was learning Envoy, it took me 3 months of really like getting something to work, breaking it, putting it back and say, you know what? Let me write the whole config by hand. Let me integrate Prometheus. Let me integrate these things. And I just wait, write down some notes, do a little tutorial, ask questions, and I say, you know what? I think I really, really understand now. Okay, so I can put it to the side.
Yes, so before I let you go, can you summarize in two or three words the past, present, and future of IT, and past, present, future of Kubernetes, and then I will let you go in a 3 or 4 sentence.
I think the past is what we serialize until the tools of today. And the things that we're going to do in the future are going to fill in the gaps of the tools we have today. That's it. So Kubernetes is taking all of the patterns of before and making them easy for people today to use them. And all those people will identify gaps and try to improve it. And that's going to make the thing that we use tomorrow.
Thank you very much, Kelsey. Tremendous stuff. I learned so many great stuff from you. The one thing that I like about you that you can describe a very gigantic concept in 3 or 4 words, and everybody able to understand that. Very few people have leverage to elaborate these complex topic in 2 to 3 words. But I have really appreciated your effort to join me today, and hope to catch up you again in future. And hopefully you have a great sleep. I meet you finally, and hopefully we can meet in person again when the COVID has gone away and is in the past, and we have to meet again in real time, face to face, might be the KubeCon, DockerCon, AnyCon. It's been a pleasure talking to you. Bye bye, Kelsey.
Awesome. Thank you. Bye.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.